and I know I'm getting totally carried away, but I just wanted to do the sine function also just because this example is a little confusing. Sine is just different than cosine, and you have to be careful with the sine function. So first I just thought I'd point out though that Dr. Forster is having trouble making up problems. You can see 2, 3, 4, 5. I think he's just a little bored. All right, well anyway, let's go ahead and graph this. We want to find the least positive value of x for which y equals 4.1. All right, so I don't know, I just like to do the graph first because I think it's helpful. So once again, let's try to actually get it on a line so that I can actually read it here. Should we do that? I don't know. Try that again. So there we go. That's not bad. Okay. Now let's see. We're going to sinusoidal axes of 2. Once again, all these problems seem to have a sinusoidal axes of 2 and an amplitude of 3. So up 3 would be my upper boundary, down 3, and then -1 is my lower boundary, kind of right here. So just sort of keep all that. My wave's going to oscillate up and down between those two right there, right? Because sinusoidal axis is y equals 2, right? And it's got an amplitude of 3. Instead of going from 1 to -1, it's 3 times 1 and 3 times -1, right? Up 3, down 3. Okay. And it's a sine function. So remember what the sine function looks like. It's going to start on the axes, go below the axes, and back to the axes. Remember the sine function like this, right? Over and over and over again. All right, so now what else do I have to keep in mind here? Oh, let's figure out the period. All right, the period. We're not theta, we're talking about radians, so it's going to be 2 pi divided by 4, which you're multiplying the argument by, so it's going to be pi over pi halves, which is very squishy, very, very squishy period. Okay. Well, I wonder if it's helpful to number the x-axis by pi's or by just regular numbers. Never quite know what to do there. Well, let's go ahead and do it by pi. But let's put pi right here. Nah, let's not. Well, let's put pi out. Let's see, 1, 2, 3, 4, 1, 2, 3, 4. Let's put pi right here. Would that be okay? Yeah, let's put pi halves right there. There we go. 1, 2, 3, 4. There we go. And then 1, 2, 3, 4. Look, that'll be pi. That'll be pi right there. So really, keep in mind that this is really about 3.14, right? It's about 3. All right. So then 1, 2, 3, 4, 1, 2, 3. All right, this is going to be, 3 pi over 2, isn't it? And then 1, 2, 3, 4, right there. And this will be 2 pi. Will this be 2 pi? 1, 2, 3, 4. This is pi fourths, pi halves, 3 pi over 4 pi. And so it's going to be a fourth more, half more. Oh, no. Okay, 1, 2, 3, 4. All right, right here. 1, 2, 3, 4. Over 1 more. All right, finally somewhere, that very last one is going to be 2 pi. All right, that looks right. Okay, now let's see. We're shifted over a half. So minus a half. So it looks like it's going to start. It's going to start about right here. Okay. Then it's going to go up, down, and then let's see, in pi halves, so about right here, pi halves, right? It'll come back down. Don't do that. And the halfway point, sorry, I don't know how to make it not do that. And then the halfway point, about right here, it'll come down. All right, so it's going to be half a circle, right? Half a circle. That's not very good. Let me try it again. Half a circle, and then here goes the other half of the circle down over there. There we go. And then let's see, it'll do the same thing. Oh, stop that. And then right here, okay, it'll come up, and then I'll come down the other half circle there. All right, cool. Ah, let's come over here. It'll do the same thing again. So let's see, just because once you get making these waves, it's just too fun. It's almost like, you know, I don't know, it's almost like a puzzle or something, right? Isn't this fun? Whee! Okay. We all have our definitions of fun. Just keep that in mind. All right, here we go. Now what? I forgot what we're doing. That's a pretty wave, though, isn't it? Hi! Okay, let me... I think I'm getting tired here. Let me see. What are we supposed to do here? Find substituting 4.1 for y. We want to find the least positive value. Okay, 4.1. So let's see where 4.1 is. Let's come over here. 1, 2, 3, 4. 4.1. All right, right there. It looks like it'd be 4.1, just slightly above the 4. So it looks like right there. Right there. I mean, it's just it's going to be really close to the y-axis. That's going to be the least positive value right there. So, you know, because this one will be the second one, positive value at 4.1. This is y equals 4.1. Right, and this is where it's going to intersect the graph there. You know, you can just see it keeps going forever, right? I mean, it's going to do it again and again and again and again. All right, so, whoops. That was supposed to... What happened there? Somehow my sign isn't up quite high enough. Oh, well, anyway, you get the idea. Let's see, this is 2, 3, 4.1. Oh, my blue line isn't quite in the right place. Oh, that's what's happened. Oh, okay. Let's see, because 2, 3, 4.1, it should be down. It should be down here. 4.1. Oh, it's a red line. What am I doing? Okay. Anyway, that's where they are right there. Okay, I really need to stop. And let's get working it out. Those are them, and it keeps going forever. Okay, so let's solve this. You know, you can see to start up here, it's going to be, can you see real easily that it's going to be 1/3, right? Y minus 2, because you just subtract 2 from both sides and then divide both sides by 3, equals, and can you even just see it's going to be the sine inverse of 1/3 y minus 2, take it right, time equals 4 times x plus 0 and 5/10. All right, now remember we're going to let y equals 4.1, right? 4.1, yep. So let's put 4.1 in there for y. And let's see, what do we get there? 4.1 minus 2, I get 2.1. And so then I get 1/3 2.1, so divide that by 3 and I get 0.7. All right, so replacing this y right here with a 4.1, I get this is going to be the sine inverse of 0.7 equals 4 times x plus 0.5. All right, so let's take the sine inverse of 0.7. So this is the tricky part right here. The sine inverse of 0.7. The problem here is, yeah, see, the problem here is, let's think about what it is. It's going to be 0.78, let's say. Okay, that's going to be one possibility, plus 2 pi n. But the problem is here, what is the next possibility? And with the sine, this gets a little bit on the tricky side. Times 4 times x plus 0.5, because it's not like the cosine where you can just do positive or negative 0.78, because remember the sine, you know, the sine, if 0.78, let's see, 1 radian is about right here, right? If this is the unit circle, this is 1 right here, right? This is 1. 1 radian is about right here. That's about 1 radian, one arc length. That this distance right here is about 1. All right, well, 0.78, yeah, what would we say? It's about right here, right? It's very, very close to 45 degrees. This is going to be about 0.78. But see, the problem is this is going to have the same sign. If I come over here, see the sign is the height, right? You got to come over here to the second quadrant, and it's going to have the same sign as this this arc length right here, this arc length right here. And that, so I don't think that's just real intuitive there, that it would be those two. Now, it's not going to have the same size. It's not going to be the third quadrant's not a problem. That's going to be a negative sign, right? And the fourth quadrant's not a problem. But see, so the sine is just a little bit trickier than the cosine. The cosine, if I were doing cosine of 0.78, it's not a problem because I would do negative. I would do, the positive 7800ths or negative 7800ths because the cosine in the first quadrant is exactly the same as the fourth quadrant. So this gives the first quadrant, fourth quadrant. So with cosine, it's no problem. Where it's a problem is with the sine. Okay, and the key here is just to recognize how do I find, how do I find this right here? How do I find the equivalent radian over here? And the way to do that, remember this is pi. So if I take this whole arc length pi and I subtract off this arc length right here, right? If I subtract off that arc length, that'd be equivalent to this one over here. Okay, what am I going to have left? Well, if I subtract that off, I'm going to have this one right here left, which is the one I want, right? All right, so the key to this is going to be 0.78 right here, and to get this one over here, I take pi minus 0.78. So I have to take, let me see what that is, pi minus 0.78. It's 2.36 radians or something like this. So let's go with 2.36. Okay, so it's going to be 2.36 radians. So it's going to be 0.78 plus 2 pi n, or it's going to be 2.36 plus 2 pi n, because you could keep circling then over and over and over again. Let me erase just plus 2 pi n equals 4. All right, hopefully that helped see the difference with the sine and the cosine, because that's the whole trick. Other than that, it's really just the same as what we've done before. All right, so we're going to take, let's see, I think I will, what's the best way to do this? Divide everything by 4? Well, why not? Let's just divide everything by 4 right now. Okay, both sides. So I'll divide all of this by 4 and all of this by 4. And so I'm going to get 0.78 divided by 4 is 0.195 plus, and then you can see 2 pi n divided by 4 is going to be pi n divided by 2, right? Or, and then now let's do the 2.36 divided by 4 is 0.59 plus, and then pi n divided by 2. Just taking 2 pi n and divided by 4 equals x plus 0.5. And now I'm going to subtract 0.5 from both of these. Okay, so 0.195 minus 0.5 is going to be, this will become negative 0.305 plus, let's say pi halves n, maybe that's easier, or, and then 0.59 minus 0.5. I think I can do that in my head. I just can't. I don't know why. 0.09 plus, and then pi halves n equals x. Alright, so now we look at all the possibilities. So let's see. If we let n, we look at all the possibilities. Let's see. Can we let n be 0? If we let n be 0, I'll get a negative answer over here, and if I let n be 0, I'll get 0.09. I'll bet that's going to be my smallest one right there. That looks like it could work. So let's start out. If we let n equal 0, we get x equals negative 0.305 radians, or x equals 0.09. If we let it be 1, but let's try that because that could be it. I mean, the 0.09 could be this one right here. Matter of fact, I think it might be. I think let's let n be 1 and let's see what happens. We have to try everything. Let's let n be 1. So we're going to get 0.195 plus pi times 1, so pi divided by 2, and that's going to be 1.71. All right, so we get x equals 1.77. 1.77. Okay. When n is 1. How did I get that? Oh, wait, I did the wrong thing. Sorry. Hang on, I'm doing the wrong thing. That's not right. Let's let n be 1. I have to use this formula right over here. This one right here. So let me be careful to use the correct one. I used the top one, not the bottom one. So let me try that again. So negative 0.305 plus pi halves, because n is 1. So pi halves times 1 is just pi halves. So let's see, it's going to be pi halves, pi 2. And I get 1 point, all right, so here I get 1.27. Okay, or let's see, now let's let 0.09 plus pi halves. Well, that's going to be more, right? Plus pi by 2. Yeah, so it's going to be 1.67. Yeah. So if n is 0, if n is 1. Now if n is 2, they're going to be even bigger. So I guess that's going to be my lowest. What if it's negative 1? I think maybe we need to let n equal negative 1. Let's see what happens. Okay, if it's negative 1, I know I'm going to get a negative over here. Negative 0.305 minus pi halves. I mean, so I know I'm going to get a negative number there. I get negative 1.88 if it's negative 1. But let's look over here. What happens here? Let's do 0.09 minus pi halves. Pi divided by 2. Oh no, I get a negative number. Negative 1.48. All right, so I'm looking like I get 0.09. What does the book get? Does he do this one right? Oh, he did. Okay, well, I got the same answer as him. So let me stop right here. So let any of you, okay, so this is what we're going with. That is going to be my smallest one right there. 0.09. Well, okay, that's it.